All right, so we're going to look at what's called quadratic identities. Now, an identity, like a trig identity, just means things that are exactly equal, or congruent if you like. So if you have two quadratics that are equal, now if they're just equal, then possibly it's an equation to solve and to find out which values they're equal for. But if they tell you they're equal for more than two values of x, then there's only one thing that's possible. We must be talking about the same quadratic. Because if you think about solving them simultaneously, if you were to draw two parabolas, they could touch each other, so meet once, if you like. They could cross over, assuming their axis of symmetry is vertical, of course. Then you can only have two crossovers unless they're the same parabola. And then one would sit on top of the other, and there'd actually be an infinite number of solutions, so they'd be true for all values of x. And so that's what I'm getting at here. Therefore, the coefficient of x squared must be the same on both sides, the coefficient of x must be the same on both sides, and the constant must be the same on both sides. So with this sort of question, I guess you're looking for them to say that they're equal for more than two values of x. The other thing they might do is use the congruent symbol rather than the equal symbol. And then if they're saying congruent, just like in geometry, it means, well, these are exactly equal. They're identical. So here's a typical sort of question. And notice I've used the congruent symbol there. So if 2x squared minus 7x minus 4 is the same as a outside of x plus 2 squared, b outside of x plus 2 plus c. Now there's two ways I can do it. I could expand the whole thing out and then equate the coefficients. Or I could use clever use of substitution. So I can, because they're the same for all values of x, I can sub any value of x I like in, and I know I'll get a correct statement. Or of course, there is a third option. You use a combination of the two ideas. So let's do the expanding out idea, and then I'll group it eventually. There we go. So I now know that the coefficient of x squared must equal the coefficient of x squared, the coefficient of x must equal the coefficient of x, and so on. So I know that a is equal to 2, 4a plus b is negative 7, which means, because we just worked out a was 2, so 4a would be 8, b is negative 15. 4a plus 2b plus c is negative 4. So again, subbing in what we've already found for a and b, we get c is 18. So there's our answers for a, b, and c. I said the other way we could do it is by clever use of substitution. If I substitute in x equals, well, I think the logical one to pick here right now would be negative 2. Because that would make both the a and the b disappear. So x is negative 2, and I get the c straight away. It works out to be, oh, strangely enough, it's 18. Now, I'll choose x equals 0, because it's always an easy number to substitute in. So I sub in 0, and I get negative 4 is 4a plus 2b plus c, which essentially is the same as saying equate the constants when you think about it. So I get 2a plus b is negative 11. I'll pick another number. 1's easy to sub into, so I'll pick 1. And I get 3a plus b is negative 9. And simultaneous equations, we get a is 2, b is negative 15. Now, in reality, the quickest way to do this, as I said, would be a combination of the both. I could have got 2 straight away by just equating the coefficients of x squared. So I would have got the answer for 2. I could have got c straight away by subbing in x equals negative 2. Well, now that I've got a and c straight away, I just sub in a number, maybe 0, and then I can sub in what I got for a and c, and I get b, rather than having to do simultaneous equations. So probably the best approach is to try and use a combination of the ideas.